The title of my project is The Effect of Various Concentrations of Powdered Petroselinum, crispum, which is also known as parsley, diluted in ethanol on the growth of E. coli. The purpose of this experiment is to find out if a herb rich in flavonoids, such as parsley, can contribute to lowering the risk, relieving symptoms, or aiding the cure of the urinary tract infection. Ultimately, the goal is to find out if a possible home remedy involving foods rich in flavonoids could be another strategy in fighting this infection. The urinary tract infection is a major issue today, mainly because of the numerous amount of cases that cost a tremendous amount of money. There are almost 150 million people affected worldwide, and in the U.S. alone, costs are around $3.5 billion per year. That includes the healthcare costs and the total time missed from work. Along with this infection comes aggravating symptoms, such as pain when urinating, prolonging pain in the lower abdomen, and frequent urination. Why is it dangerous? If a UTI goes untreated, it can become a kidney infection, and kidney infections are much more serious due to the likelihood of the infection traveling to the bloodstream, causing a response of the body known as sepsis. Sepsis occurs when the infection triggers a chain reaction throughout your body, leading to many organs becoming affected, and then it is usually deadly because of the amount of organs that fail. Speaking of sepsis, it is just like a wildfire. The more time a wildfire is left unnoticed, the more wildlife and trees are affected. The longer sepsis is left untreated and uncared for, the more number of organs fail and become damaged. And wildfires are life-threatening to the species and wildlife, just how sepsis is life-threatening to the body, ultimately resulting in death. Most of you may know how parsley is a herb that comes up a lot in your food, such as the dash of parsley sprinkled on your tacos and salsa. What makes parsley a great candidate for an alternative strategy in managing the urinary tract infection is that it is abundant in flavonoid. It contains a lot of flavonoids. You might be wondering, what in the world are flavonoids? Well, flavonoids are one of the two most common antioxidants, the other being polyphenols. They are various compounds found naturally in many fruits and veggies, and their content varies in each food. For example, parsley contains a large flavonoid content, but if you compare it to lettuce, lettuce has a lot lower flavonoids than parsley. The reason my project focuses on these plant chemicals is because research has shown that flavonoids are actually studied to have antibacterial activity, and my project's focus is to fight against a bacterial infection. The powdered form of parsley will be used because powdered substances are linked to more solubility, whereas using the oil form, for instance, can't really dissolve well in my solvent ethanol. Additionally, part of my independent variable is altering the amounts of parsley powder diluted in ethanol. The reason for that is that it would show the effect of powdered parsley on E. coli more clearly. As the title of my project stated, I will be using ethanol to dilute the powdered parsley in. This is mainly because ethanol is a polar molecule. It can dissolve both polar and nonpolar substances. This is so appropriate to use in my experiment involving the extraction of flavonoids, since flavonoids contain both polar and nonpolar classifications, which means they have both polar and nonpolar molecules. Therefore, ethanol will be able to dissolve them well. Also, an experiment performed on various solvents like methanol and acetone on one of these plant extracts called L. aromatica. That study concluded that the most antioxidant content yielded was when L. aromatica was diluted in ethanol. Lastly, ethanol is one of the safest alcohols to use in the lab compared to other alcohols due to its low toxicity. My hypothesis is that if a higher concentrated dilution of parsley powder in ethanol is placed onto E. coli, then the growth will be inhibited more than a lower concentrated dilution placed onto E. coli. All of the different experiments proving the antibacterial function of flavonoids on bacteria will have an impact on the growth of bacteria. And because a larger sample suggests there are more flavonoids, testing different concentrations of the dilution will bring a change in the amount of growth inhibited. Here is my procedure visually. I have 6 Petri dishes, 3 in the experimental group and 2 in the control group. All of the yellow represent the E. coli, and they each have the same amount of E. coli. In my experimental group, dilutions are placed with a micropipette. They are various concentrated dilutions. For example, here is the lowest concentrated dilution with only 1 gram of parsley powder diluted in 10 ml of ethanol, and here is the highest concentrated dilution with 3 grams of parsley powder diluted in 10 ml of ethanol. In my control group, there is a Petri dish with only E. coli with nothing added to it. This is there to reveal if the experiment actually works so that I can know how much growth E. coli would actually grow without anything added. And the other part of my control group is just adding ethanol without any parsley powder diluted in it. A qualitative collection of my data would consist of observing any specific locations on the Petri plate of where colonies were inhibited and comparing it amongst the other plates. My data will be collected quantitatively by measuring the number of colonies that grew or died every 2 days. The data will be collected in data tables. These data tables will contain the number of E. coli in colony forming units about every 2 days. It would show the results for all of the various concentrations as well as the control groups. Here on this data table, it will show the number of E. coli before the dilution was placed and the number of E. coli when the experiment is over. What does the data tell us? Going off of my hypothesis, if the E. coli that received the highest concentrated dilution takes the least amount of days for all the E. coli to be killed, that indicates parsley played a great role in inhibiting the growth of E. coli. Likewise, if the difference between the number of E. coli before and after the experiment is the smallest, meaning a greater death in the E. coli by the end of the experiment, that will also reveal the great role of parsley in the amount of E. coli growth inhibited. To conclude, I want to reiterate that the goal is to find out if parsley can be an alternative strategy in helping to reduce the risk and lower the amount of UTI cases that occur every year. By conducting this experiment, a possible strategy can be brought to combat and prevent this aggravating infection so that, in turn, the risk of it spreading like a rapid, life-threatening wildfire can be minimized. Thank you.